This is my rigid body equilibrium reassessment. And this question is: a man is doing push-ups. He has a mass of 68 kilograms and his center of gravity is located at a horizontal distance of 0.70 meters from his palms and 1.00 meters from his feet. Find the forces exerted by the floor on his palms and feet. So here's our man, who also happens to be Allain. His center of gravity is here. The distances are here. This is the force of his palm. This is the force of his feet. This is the weight of the man, which is equal to mg. His mass, 68 kilograms, times gravity, 9.8, is equal to the weight of our man. So we come here, the summation of the torque is equal to 0. And this is also the summation of the torque around a point is equal to 0. And so right here we have all of our torques. So we have torque of the palm minus the torque of the feet plus the torque of the center of gravity. And so I put the minus signs for here because if we took everything away and we just used this force, then it would cause it to rotate in a clockwise motion, which would make it negative. And if we took everything away and just pushed down here, then it would cause it to rotate in a counterclockwise motion, which would be positive. Hence the reason to do that here. So right here, summation of the torque around the point is equal to 0. I pick the palm as my point, so that means that's going to be 0, because torque is equal to the force that is perpendicular to the point times r, the distance from the point. So we have the torque of the feet, and the torque of the center of gravity is equal to 0. So we have negative force of the feet, 1.7, because 0.7 plus 1, that's how far it is away, plus weight times the force of the center of gravity, which is weight, mg, plus 0.7, because that's how far away it is from the palm. So you add that, plug in what you know, multiply it out, and you're given 270 newtons is the force of the feet. This is force of the feet, excuse me. If I said force of the palm, didn't mean to. Now we come over here, so we hit the summation of the torque around the point is equal to 0. We're going to pick the feet as our point, which means that's 0. So then our torque around the palm is here, and our torque around the center of gravity is here. Move it to the other side so it's not negative. And so we're given our force of the center of gravity, which is also equal to the weight, which is mg, times the distance from the feet, which is 1 meter. And then our force of our palm, which is 1.7 meters away. So we plug in what we know. 68 times 9.8 times 1 divided by 1.7 is equal to 390 newtons. So the force of the palm is 309 newtons, force of the feet 270 newtons.